Assalamu alaikum wa rahmatullahi wa barakatuhu. Good evening, everyone. I am Muhammad Umar, General Manager at Tawakkal Group, and it is my great honor to welcome you all to today's online session. To begin this program with the blessing of Allah Almighty, moving towards today's theme, let us briefly recall our previous session where we had the honor of learning from Professor Aipong Hari Parwanto on PL stocking in shrimp farming. Professor Aipong highlighted that the success of shrimp farming cycle began with proper PL stocking. He explained the importance of selecting healthy, active, disease-free PLs, gradual acclimatization to pond salinity, temperature, and pH, choosing suitable stocking density according to the farming system, gentle handling techniques to reduce stress and mortality, continuous water quality monitoring after stocking. That session emphasized how strong foundations and stocking ensure higher survival, growth, and profitability. Today's discussion builds upon this knowledge by focusing on advancements and innovations in aquaculture and shrimp farming. The theme of our session is Advancement in Aquaculture and Shrimp Farming. Aquaculture is one of the fastest growing food producing sectors worldwide, and shrimp farming lies at its center. Through modern research, technology, and sustainable practices, this field is evolving rapidly to meet global food and economic demand. We are truly honored to have with us Dr. Aya S. Hussain, originally from Egypt and currently in the USA for her postdoc research. Dr. Aya completed her PhD in aquaculture and fisheries from Auburn University, Alabama, USA, focusing on Pacific white shrimp in low salinity waters and thermal tolerance. She also pursued a minor in statistics and earlier studied marine science at Suez Canal University, Egypt. Presently, she is serving as a postdoc research associate at Purdue University, Indiana, USA, while also being a lecturer assistant at Swiss University, Egypt. With over 12 years of academic and research experience, her expertise covers shrimp farming, integrated aquaculture, and aquaponics with focus on sustainable systems. Her inspiring journey from Egypt to USA reflects dedication, knowledge, and international contribution to the aquaculture industry. Without further delay, I would like to warmly invite our honorable guest, Dr. Aya Hussain, to deliver her talk on advancement in aquaculture and shrimp farming.
Bismillah ar-Rahman ar-Rahim. Assalamu alaikum, everyone. Thank you so much for having me here today. Um, this is the topics we gonna be covering today in our session. But before we begin, I would like to thank you all again for being here and having me. I'm very pleased to be among you and share my limited experience with you. I'm also pleased to be to share with people from Pakistan. I know it's the fifth populace in the world, and it's known for producing a lot of vegetables and for being champion in cricket and hockey. So it's a real pleasure to me too. I also see a lot of females among the audience, which is amazing. I'm one of one example of those females in aquaculture. So it's always a pleasure to me to see this big number of females in audience and interested in aquaculture. So before we begin, this is my bio. Thank you so much for the introduction. I just wanted to highlight that I'm from Giza, Egypt, which is known for the pyramids. But let's move onto the important topic. We'll start with the background of our topic first, then we'll talk about biofloc technology, and we'll summarize what we talked about today. So as we, excuse me, As we all know that producing diverse food is in a sustainable way is crucial. And blue food, which is a new term used interchangeably with seafood, can combine all aquatic animals, which is fish or shrimp, plants and algae, which all can be produced in a more sustainable way than land-based food. Pacific white shrimp is the most commercially important species worldwide nowadays. And we'll talk about why it is important. If we look at the figure at the bottom here, we can see in the latest year, the production have increased, especially in Asia, in the Americas, and other parts of the world. So it's very important to maintain good life cycle for this shrimp to get good performance as well as profitability of the aquaculture. So Pacific white shrimp is known for its high value, strong market, fast growth. It's one of the fastest growth, highly efficient in converting feed, disease resistant, salinity tolerance. For example, it can tolerate between zero 0.5 up to 50 ppt parts per thousand. And it's known to tolerate also very high stocking densities. It can be stocked at, for example, 350 shrimp per cubic meter. Similar to any other organism, Pacific white shrimp require certain requirement in their diet. For example, the dietary protein is between 18 and 35 based on literature. The carbohydrate is 40, the lipid between 5 and 8. But when we feed this commercial feed or even homemade feed to the shrimp, there will be excess nutrients in the water, even from leftover feed or from the feces, feces or fecal material from the shrimp. So this nutrients and organic matter can lead to environmental problems. And it's very important for us to understand the nitrogen cycle in our culture system, either for shrimp or any other organism. For example, if you look at the figure down here, let me bring the mouse. You can see the nitrogen cycle start with ammonia, which is the most toxic to shrimp. Shrimp also, unlike fish, is very sensitive to ammonia and nitrite. So it starts with the peak of ammonia, followed by this peak of nitrite, and then lastly the peak of nitrate, which is the least harmful, but also can be toxic at very high concentrations. So anyone is culturing shrimp, usually focusing on intensifying their culture to get the most benefit out of this culture, right? So with the intensification, there is always this rising concerns, such as effluent discharge to the environment, the excess feed, like we discussed, disease outbreak. If it happened in one farm or one pond, it will transfer to the surrounding farms. Environmental impacts such as eutrophication. If we discharge this high nutrient-rich water to the nearby water body, there will be eutrophication, right? So with the intensification, aquaculture is known to suffer from overcrowding, disease, and mortalities. And in the past, antibiotics have been used in aquaculture to minimize or to solve this issue. So when disease happen, usually we would apply antibiotic to the aquaculture system. But there is always concern with using antibiotics. So if you look at the right side figure here, you can see with the use of antibiotic in the water, the fish will consume it, then the fish will go to the market, then to the human food, and then there will be always this concern about antibiotic resistance, toxicity, and allergies. So it's very important for us to find environmental friendly systems that we can manage, and in the same time we can control biosecurity in the system. One of those good systems that have been known in the last 10 or 15 years is biofloc technology. And that's what we're gonna be focusing on today. So biofloc, this is just the definition, is a technique of enhancing the water quality by producing this microbial floc or microbial protein, which is known as biofloc. So the animals can consume it. So it manage the or control the water quality and then produce this microbial floc, like we will discuss later on. And then the animals can consume it. So it's a win-win situation for everybody. So this is how biofloc works. Usually we feed the shrimp up here in the top left corner of this figure. You will see we apply or add the feed the shrimp. Then there will be leftover or inorganic nitrogen from the leftover feed, from the feces, and then from the leftover feed. All of this inorganic nitrogen in the water, in addition to an external carbon source that we add to water, basically we feed this microbial communities with the carbon source. So an example for carbon source is molasses, even simple sugar, rice bran. There is a lot of examples. So when we add this carbon source, in addition to this inorganic nitrogen, you get these flocks. And this is how the flock looks like under microscope. So usually there is bacteria in the water. There is bacteria everywhere, right? There is bacteria in the water. So when we feed it with this external carbon source, in addition to the nitrogen that already exists in the culture system, the bacteria uses this nitrogen and carbon to build more cells. So they multiply and make these little flocks that we can visually see in the water. Of course, the system have to be maintained in always aeration and mixing to maintain for the oxygenation for the shrimp, not only for the shrimp, but also for the microbial communities as well. And like we discussed, there is multiple carbon source that can be used. So for example, there is molasses, there is tapioca byproduct. I believe it's named cassava in Pakistan. There is rice bran. Usually the most common ratio used in biofloc systems is 15 to 1, so 15 carbon and 1 nitrogen to maintain a good biofloc system. So what's this biofloc composed of? Is it just bacteria? Actually, no, it can compose other microorganisms as well. As you can see in the pictures here, it can contain chlorophytes, rotifer, nematode, protozoans, diatoms, and many others. It can also contain fecal remains. It can contain leftover feed, some exoskeleton from shrimp molting. But the key factor to all of this is the management to this biofloc system. You can't just add carbon source and expect the system to work, or just feed the shrimp and expect it to work also. There is multiple key factors that we need to consider. For example, the number of animals, the animal density that we stock in our system. The more animal you bought, the more feed you supply, the more nutrients there will be in the water. And also the type of feed will determine the type of nutrients. So for example, are you using 28% feed, or are you using up to 40% feed, or even 50 for younger animals? This all will determine the carbon to nitrogen ratio in your system. So, excuse me. So the carbon addition also, which is the carbon to nitrogen ratio, you need to maintain. Are you using 15 to 1 like we discussed, or are you using lower or higher even density? So if you're using higher carbon to nitrogen ratio, you will need to remove some of these solids, because if these solids go above certain level, and we will discuss this recommended level, This solid can even interfere with the shrimp health, so it can get into their gills and block their gills, and they will not be able to breathe. There is the lighting cycle, and we will discuss why is this important as well. So there is different biofloc system types, like we discussed before. I remember in Brother Ebong presentation, he briefly discussed how the phytoplankton presence in the water can affect the different coloration. So we will elaborate on this now. So the first system type is the photoautotrophic, which is the green. So as you can see in the picture here, it's just green water, right? Like we see in the ponds. This is the most commonly used commercially. Usually low stocking density of shrimp is used, about 200 shrimp per cubic meter. There is different types of lighting. Usually it would depend on natural light, which is of course cheap, but in the same time it's inconsistent. So it can lead to algal bloom. You can also supply artificial light, fluorescent or LED. It will all come down to price and energy cost. It can be done in ponds, a greenhouse, or even sometime indoor, if you have enough lighting. The second type, which is the most commonly known for as biofloc system, is the brown, the heterotrophic systems. In this system, you can use animal density between 150 up to 350 shrimp per cubic meter. In this case, it's recommended to keep the carbon to nitrogen ratio between 10 or 15 to 1. Low protein diet can be used because there will be enough or sufficient of this microbial protein that the shrimp can consume. So you don't need a high protein feed. But also the additional carbon source that you add to maintain this 15 to 1 will add to your cost as well. Because the system is dominant for their is dominated by the good bacteria, the heterotrophic bacteria, it usually compete with the disease, with something like Vibrio, which is a major concern to shrimp. So keeping the shrimp in a healthy condition. And the main benefit of having this type of system, that the bacteria, the heterotrophic bacteria, use the nitrogen that from the inorganic nitrogen, from ammonia nitrite, to build their cells. So not only they are removing this inorganic nitrogen, the unwanted nitrogen in the water, they also producing this microbial floc. So they build their cells. So they benefit the shrimp growth as well. So this microbial protein is nutritious. It can help in lower the FCR. It can also end up with high growth rate, fast growth rate as well. But in the same time, as you can see in the picture, and if you saw in the previous video, it requires high oxygen demand to maintain both the shrimp and the bacteria in the water. The third type of system is the chemoautotrophic, which is a combination between the previous ones we discussed, the photoautotrophic and the heterotrophic. So it's a mix of green and brown systems together. In this system, you can use high stocking density, 350 shrimp per cubic meter. Usually the greatest production, as you can see, the more shrimp and the more mature the system gets, the more dark the water gets as well. If you see from the top left corner until the bottom right corner picture. In this case, you can use low carbon to nitrogen ratio, 9 to 1, because the system is not dominated by bacteria in this case. There is algae and there is bacteria. There will be still microbial nitrogen assimilation because there is still bacteria or heterotrophic bacteria in the system. It's very reliable once established. Again, it's mixed between bacteria and algae, but it takes some time to be established. To get this good coloration in the water, it takes some time. So the benefit for the chemoautotrophic is less solids in the system, but in the same time, there is always the oxygen consumption by the bacteria. Um, but in this case, in the chemoautotrophic, the oxygen consumption is lower because there is algae in the water, not only bacteria. Algae photosynthesis, and they release oxygen during the day. Then they consume the oxygen in the night. So you may need to supply only oxygen, for example, during the night. You don't need to have the aeration on all day. Um, Usually it's a mix again between heterotrophic and photoautotrophic. It's hard to tell which one is more dominant. It depends on how much lighting you have in the system. It's usually have less microbial management or less microbial communities, because once you have, for example, sunlight or natural light somehow, even in indoor system, the system will be dominated by algae. You will obviously see the green color right away. But if you have enough bacterial community and you supply this carbon source, you will have some bacteria as well. So it's a mix of both. You can get, this is one of the disadvantage, is you can get the buildup of nitrate over time, which can get toxic at a very high concentration for the shrimp. This is coloration index. Researchers developed to kind of measure what color are you in your system. So for example, if we start at the left top corner, you will see it starts with green. So mostly algae, goes down, and there is a mix of both in the middle here, and then goes down to brown, just brown color at the bottom, which is mainly heterotrophic bacteria. So what type of system, again, what can we use in bioflux systems in those three system types? You can use ponds, which is most commonly used, but you will have to have a strategic aeration, like we see in those pictures here, to maintain both the shrimp and the microbial communities. Usually it reflects the green water system, but you will have to have the pond lined or concrete pond. So in this case, when we have this much aeration and agitation in the system, it will also disturb, for example, if you don't have the pond line, you will disturb the surface layer of the soil, right? So these particles will be suspended in the water column as well. And this will cause harm to the shrimp. So it can get to their gills, it can block their gills, and you will end up with mortality. And this is the opposite of what we want, right? So you will need to almost isolate the pond from any dirt or any surroundings. So the ponds have to be lined in this case. Also, you can have it in greenhouse. It can be expensive, although it can get to expensive greenhouses too, if you have multiple layers, if you have good insulation, especially if you are in cold area. But in the same time, this allow you to have more biosecurity, more management in your system. You can run it year round. If you get to even colder winter, you can maintain it in the winter because you can control the temperature in your greenhouse. It can be done also in solid buildings. So it's again controlled, the thermally insulated or thermally controlled. You will have high biosecurity, so no one is just going in and out of your farm. You will have consistent condition year round, but of course you will have a high energy cost. You will have a big energy bill. It depends on the lighting will determine, is it dominated by algae or is it dominated by shrimp, by bacteria, excuse me. These are just some pictures from worldwide, from for biofloc operations worldwide. If you see in the top left corner here, this is conducted is in tanks. The right side top here is in ponds. The two down below is in greenhouse. So we discussed about the certain level that you would want to maintain the system. So this is the most common way of measuring a biofloc, is using this Imhoff cone. If you see the middle picture here, this is called Imhoff cone. So you would want, this is the steps, the picture on the left side, this is the steps of how we can measure it. You need to collect 1 liter of water from, let's say, 2 different places in each pond. Let it sit for 15 to 20 minutes and read this amount in milli per liter. So as we can see, there is different concentrations here, starting from 5 up to 50 ml per liter. You can have a biofloc system with this dense bacterial community, but it's usually not recommended, because if it gets above this level, then it's interfering with the shrimp health. We usually maintain the biofloc system at the bottom, at the lower side of things. So we maintain between 5 and 15. Usually the recommended ratio is 10 ml per liter. Some of the benefits to the biofloc system, this is just to summarize what we discussed throughout the presentation. So low water exchange, you can maintain the same water for different cycles. So for example, if you have tanks like this farm, for example, you can, if you want to harvest your shrimp and you want to access all of them, you can drain one tank into another, harvest all of your shrimp and transfer this water back. So you reserve this water. You can reserve the salt as well. If you are culturing shrimp, as we discussed, they can tolerate different salinities throughout their life cycle, but it's usually recommended to keep the salinity around 4 ppt for shrimp to keep a good osmoregulation for them, to get a good growth. So if you are using salt or even seawater and you want to reserve this salt, it's, you know, it's expensive. You can also maintain or reuse this water again. You can go from intensive to super intensive culture as well, because the availability of the natural food, the microbial and algal biomass. The main idea or the main core of the biofloc is maintaining the water quality. So like we discussed, they consume this unwanted, this toxic nitrogen to build their cells. So this way they are maintaining the water quality for us, and in the same time producing this additional food that is available 24/7 for the shrimp to graze on. And that's what we can see in the top, on the bottom picture here. So when we add the feed plus the carbon source, you will end up with, of course, the fish or shrimp will graze on, will eat the feed, and the bacteria will use the inorganic nitrogen plus the carbon to build this biofloc. So you will get enhanced growth rate as well. One of the other benefits to biofloc systems is the immune system, enhancing the immune system of fish and shrimp. But in this case, since we focused on shrimp, it's more beneficial actually to shrimp, and we will discuss why now. So if you look at the picture here, on the left side, you will see fish. So fish is vertebrate, like human. They have non-specific and adaptive memory. So imagine like us human, when we are born with the non-specific immune system. This is what Allah created us, right? And then when we grow up, we adapt, we develop this adaptive memory against disease, against even from disease we got while we were a child, or when we get immunization, for example. So it's almost the same case with the fish. On the contrary, the shrimp don't have this adaptive memory, so they only have the non-specific immune system. So they have to be almost supplied with external source of this memory or this defense mechanism. And that's what the role of the microbial communities comes in. Their cells have metabolites which act as immune stimulants to the shrimp. So they can't defend themselves, right? Because they don't have this adaptive memory. But the bacteria around them can defend and can dominate the system, preventing any other disease to come to the shrimp. So we focused a lot on the advantages of biofloc system. Now let's talk about the disadvantage. So the main issue with biofloc is the reduction of pH because of the nitrification, the continuous nitrification of the bacteria. So you will always need to keep an eye and maintain the pH in your system. It needs a lot of irrigation, which mean a lot of power. And if you are using ponds like we discussed, you will need the ponds to be lined. So this is related terminology that is known when it comes to biofloc systems. So probiotics, which I'm sure most of you have heard it already. This is just the live bacteria, so live microorganisms that is found naturally in the water. But in this case, you can actually buy it from a company, let's say, and give your system a boost or a jump start kind of thing. So it has many benefits. So it offers alternative to antibiotics. So instead of you adding antibiotic to, let's say, resolve a disease issue, or you want to protect your shrimp from outside disease, instead of adding antibiotics, it's now recommended to add this probiotic to the system. It's becoming more and more popular. And also it's giving the shrimp good growth and prevention to disease like we discussed. So there is many benefits to probiotics. Again, it's almost the same idea of the biofloc, which is the bacteria that is naturally found in the water. But in this case, you buy it from an external source, or you get it from an external source. So it enhances the feed utilization and efficiency. It balances the intestinal gut or the microbiota in the gut, in the shrimp or even fish. Disease resistance, enhanced survival, and also one of the good benefits is the predigestion of anti-nutritional factors present in mixed feed, which is usually the plant-based feed. Another term that is used with in those systems is prebiotics, which is basically the substrate or the carbon source that we have been discussing throughout this presentation. So it's the non-digestible food ingredient. So it's the base that the bacteria uses to build their cells or multiply their cells. This is just another fancy term to carbon source. And symbiotic or aquamimicry, if you have heard this term. So it's the combination between probiotic and prebiotic. So when you get probiotic, sometimes the company require you to ferment this bacteria before you add it to the system. This is basically this fermentation process. So when you have probiotic plus prebiotic, which is the carbon source again, plus this fermentation process, usually it's aerated fermentation process, you will get this symbiotic. So what's the difference, or what's the benefit between symbiotic and the traditional biofloc or the probiotic, let's say? Why can't we just bring the probiotic and add it to the water? So usually the bacteria have a short lifespan. So if you just bring it, add it to the water, and it just few bacteria, let's say 10,000, 10 million bacteria per gram, let's say. In this case, the bacteria won't last long in your ponds, and in the next day you will need to add again. But this fermentation process allow the bacteria to multiply, so and use the carbon source or the prebiotics to build more cells. So instead of this 10 million, you get 100 million or even more cells, and then you add it to the system. So you sustain this biofloc system much longer time than the traditional even biofloc system. And this is a recipe from one of our colleagues who's have used it in multiple places around the world. If you can see, they use rice bran as their carbon source. They add some enzyme with the probiotics, and then they use molasses as their carbon source. In this case, they use seawater because they add it to shrimp farm with the constant irrigation for 24 hours, and then they add it to the pond. So lastly, we came to our summary today. So as we have seen throughout the presentation, that bioflux system have different compounding factor. They have advantage and disadvantage. So it all comes down to management and cost in the same time. But the microbial community can help in converting this inorganic nitrogen into something useful, the microbial biomass or microbial protein. By the shrimp consuming this microbial protein, it actually can help lower the FCR, and you can use even lower protein feed or lower amount of protein of feed because the shrimp are grazing on this natural food source. So it helps us aquaculture grow toward environmental friendly technique or approach. It can help also replace protein content in shrimp diet, or at least decrease its dependence on fish meal. So as we know, fish meal is decreasing, and there has been a lot of attention toward finding alternative protein sources. This also novel technique can be financially profitable if managed well. So this is a video from Kentucky State University. I don't know if we will have the time. I want to allow time for questions at the end. You are welcome to check it out. This is one of the world experts in biofloc technology, my colleague Andrew Ray in Kentucky State. So this is the link if you would like to check it out later on. And we came to the conclusion of today's presentation. I would like to thank you all again for being here and allowing me to present. I also feel deeply sorry for the flood, the climate change causing the cloud burst in northern area of Pakistan in Punjabi province. I'm really sorry to hear that a lot of people and have been displaced from their area. I would like again to thank you all for your attention. A special thanks to Mr. Janjua, who have been a great support and who invited me to this presentation today. Thank you all, and I would be happy to take any questions now.
Jazakallah. What an enlightening and inspiring presentation we have just heard from Dr. Aya S. Hussain. Your words have opened new horizons for us. You not only shared the latest advancement in aquaculture and shrimp farming, but also gave us a clear vision of how innovation, sustainability, and practical applications can transform this industry. On behalf of Tawakkal Group and all participants, I sincerely thank you, Dr. Aya, for your valuable time and knowledge. Now, we
Thank
would
you.
like to move towards the question answer session, which is an excellent chance for participants to directly interact with our honorable speaker. Participants may raise their hand if they wish to ask a question directly or simply type their questions in chat box. We encourage everyone to take part, so opportunities to learn from international experts are rare and precious.
Thank you.
Assalamu alaikum.
Walaikum salam.
Here is Dr. Razia Liaquat from Lahore College for Women University. I have actually two questions.
Yes, please go ahead.
Okay. First of all, it was my pleasure to have session with you. It's a very good session, actually.
Thank you. Thank you. I really appreciate it and appreciate your presence here today.
Okay. Secondly, my first question is: all the systems that we have discussed are for all the shrimp species, or it is specific for Pacific white shrimp,
That's a
and
great
all the
question. Thank
strategies
you.
that we discussed?
Yes. Yes. That's a great question. Thank you. You can have different species in biofloc system. You can have even fish. The problem with the other species is, for example, monodon was the one of the most commonly cultured and still is, but Pacific white shrimp is the most dominant now, right? Monodon is has cannibalistic behavior. Nowadays, people move toward Pacific white shrimp because they are less aggressive, less cannibalistic. Um, there are also other species that can be found worldwide, which is such as indicus, green tiger shrimp. There is many, many more. The problem is none of them have the good feed conversion, the good fast growth rate, that Pacific white shrimp has. So that's why most of the research has focused on Pacific white shrimp, either here in the
Okay.
US or even in Egypt. So Egypt, Pacific white shrimp wasn't native to Egypt. They introduced it in the latest years. I would say in the last 5 to 6 years, they have been trying to, or they obtained the PLs from the US here, and then they transfer it over there because it wasn't native. And they have been. I heard that there is good accomplishments there. So that's the main
Okay.
reason
Thank you so
people
much.
use Pacific white shrimp. Mhm.
Okay. Secondly, as we discussed about the heterotrophic system, so heterotrophic bacteria in heterotrophic system utilize the organic carbon, but what implications could occur in the water quality and on the shrimp health as well?
I'm sorry, I didn't get your question. So we add the carbon,
Okay.
right?
Yes. I said in heterotrophic system, the heterotrophic bacteria actually utilize the organic carbon. But if the carbon will be present in the water, what will be the implications could occur in water quality and shrimp health as well?
Oh, you mean if we add like a big amount of
More carbon. Yeah.
carbon, would this
Yes.
affect? Of course, it can affect.
Yes.
That's why we want to maintain it in this certain level, the recommended level. That's why the pioneers of this field have conducted this many research to see what's the best ratio, right? Something to consider also is the feed usually have carbon, right? We bought wheat, we bought different types of carbon in our feed, or our not our feed, our shrimp feed. So there is naturally carbon in the feed that is usually some of it in the water. But it's known also that this amount of carbon is not enough to enhance. So you will have some bacteria, so just single cell bacteria in the water, but you will not have enough bacteria to multiply and make these little flocks. You get my
Okay.
point?
Thank you so much. Okay. Yeah. Thank you so much. Thank you
But
so much.
like I discussed, if you add so much of that carbon, you can get also so much of this flux that it can actually interfere with the shrimp culture. Thank you.
Anyone from the participant who want to ask question? It is the great opportunity for all.
I hear someone is talking. Can you speak a little bit loudly, please?
Okay, we have Dr. Alamgir Akhtar Khan. He want to ask question. Please go forward.
Please go ahead.
Yes, ma'am, it's really wonderful presentation. I was fully
Thank you.
absorbed to learn. But I have a very simple, innocent question. Like if we, as I learned during the presentation, you probably have some proposal to inoculate some bacteria to activate the system. But in our case, temperature is normally very high. You think the inoculation will help in high temperature as well?
How high are we talking?
Like in Pakistan, mostly like this, we are promoting these shrimp in Muzaffargarh where temperature go as high as 45 or 47, even touches 50 degrees Celsius. Then in that temperature, then how the bacteria will survive, especially the inoculation.
That's a good question. Thank you. So bacteria actually, the high temperature can be, of course, good and bad, right? So it can be good and bad for the shrimp. It can be good and bad for the bacteria. So bacteria prefer high temperature. So let's say that's the recommended ratio, 28 and above, 30 and above. Um, I would say the 45 can damage some of these flock cells because, such similar to shrimp or similar to any other living organism, they can tolerate it until certain points, but the weak cells, let's say, they can't tolerate this high temperature anymore. So I guess in this case, you will need to keep adding. So like we discussed in the fermentation process and the symbiotic, you can ferment it and add it, let's say, every 3 days instead of every day, like a traditional biofloc. But in this case, because you are losing some of this floc or the bacteria you are adding to the water, you may need to take the volume of your flocks in the water, and if it decreases, because the cells, if they break down, you can't see these flocks anymore, right? So in this case, you will keep fermenting and adding. Unfortunately, it's an additional cost, but I don't see another way of doing it.
All right, thank you.
Thank you.
We have another participant, Risha Fatma, who want to ask a question.
Please go ahead.
Assalamu alaikum, ma'am. It was
Walaikum
a
salam.
wonderful session with you. I just want to ask a simple question. As the shrimp farming in Pakistan is in its initial phase, and the stocking density is a major factor contributing in economy of overall success of the farm. So, what parameters or what measures do you think are most essential for maintaining it and suitable for 1 to 1.5 acre farms?
So you mean what water quality parameters you need to maintain, right? Just to clarify, I got your question right.
Ma'am, most of the stocking density here is almost 30 to 40 pieces per meter square in 1 to 1.5 acre farms.
Mhm.
Pond. So, what practices do you think are most essential to increase it for better, production purposes and for better economy? Like in
Well,
biofloc, you are reaching it to 350 pieces per meter cube, which is a very good in in terms of production and economy and
mhm,
sustainability as well. So
mhm,
I am asking this question for Pakistan, as here there is no biofloc technology still for shrimp farming. So what practices
mhm.
can be done in initial phase to maintain these things?
Um, I would say biosecurity is one of the big concerns and very important to maintain in your farm. Shrimp are very sensitive, unlike fish. Like we discussed in the presentation, they don't have this adaptive immune system, right? So they are very susceptible to any disease. So you want to maintain good water quality. So biosecurity, of course, will be the first of all. You want to maintain good water quality for your shrimp. You want to measure. So, for example, in our research facility, we measure DO, dissolved oxygen, temperature, salinity, pH almost every day. Not almost every day. Sometime or in experiment settings, we measure it twice a day. I know in real world, this might be challenging to go to the farm and measure twice a day, but at least keep it a good habit of measuring once a day. So you know For example, if you lost irrigation, like all of a sudden, what was your irrigation the day before or the morning before? Um, you want to know what your temperature, so you can make a wise decision on when to harvest, because if the temperature can get to 45, like our brother discussed, you may need to plan for a little bit early harvest so you don't have mortality, or you don't cause issues at the end of your cycle when the shrimp get bigger and more susceptible to environmental stressors. So dissolved oxygen, temperature, salinity, and of course in shrimp also culture, ammonia nitrite is the main issue. And nitrate is the least concern because, like I said, they don't it's not toxic. That's the first part. The second, if you exchange water and maintain a good water quality, it doesn't get to that toxic level right away. It takes time to reach that. So measuring water quality, maintaining good biosecurity, sampling also. One of the good practices is, let's say every week or every 2 weeks, um, if you have this feed tray, you can just spray some feed and put it to the bottom, and then raise this feed tray so you can see how big, how small your shrimp are. Are they diverse in size? Do you need to add, is there leftover feed at the bottom? Do you need to add more feed, or do you need to decrease the feed? There is a lot of leftover. All of this is good keys to good management strategies. I hope I answered your question well.
Yes, ma'am, you have answered my question very well. Secondly, it's just my a little question, or maybe you can say something I just want to ask from you. In my perspective, our most of the research is basically focused on commercially important shrimps. We just focus on commercially important shrimps. But don't you think so? That's why ecological important shrimps are ignored in such a way that our overall climate changes and different drastic behaviors are uh, causing their mortality, and we are not figuring out what are the exact figures of ecological important shrimps that are also important, uh, similarly to commercially important shrimps like goose shrimp and cleaner shrimp. They are most important for sustainable nursery habitats and for mangroves, where there is a breeding ground of shrimp. These shrimp species are also very valuable, but our research only focuses mainly on Lithopenis monomy and monodon, which are commercially acceptable from more market point of view.
So I guess your question, why is research is focused on these species, right?
Yes, ma'am.
So like I discussed with Razia, the Pacific white shrimp has gained a lot of attention lately because of all of the good um, things that comes with it, the fast growth, the less aggression. I personally was culturing one of our native species in Egypt in my master's, called green tiger shrimp, Beneas semisulcatus, and it was very cannibalistic, very aggressive toward other shrimp. Unlike Pacific white shrimp, throughout my career, I cultured Pacific white shrimp. They are the least aggressive. They are the least cannibalistic. So what I'm saying is, for the monodon, let's say, or the green tiger shrimp, you can see the cannibalistic behavior. You can see one shrimp is going after another and like eating it almost while it's molting, or during a vulnerable period. But Pacific white shrimp is the opposite of this. They can be molting in clear water system. They don't mind each other. They almost don't care. If you feed them well enough, if you maintain good water quality, they just, staying there and eating their food. That's one of the main good reasons that Pacific white shrimp gained this attention throughout the world. Um, Monodon, like I said, was the top candidate for shrimp culture, but after people, because of it's a little bit slower, has a little bit slower growth rate. The hatchery phase is a little tricky. to hatch the shrimp. Unlike Pacific white shrimp, it's much easier. And a lot of hatcheries had success with the Pacific white shrimp. That's why they moved toward it. For the other species you mentioned, maybe some of them are native to certain areas. So in the US, for example, we don't have access to those species, and the regulations, people can't just bring shrimp from outside and do research or culture it in their systems. They have to have certain permissions, they have to have a lot of regulations. So I would rather, just because it's native to the East Coast here, I would rather to just get one of our native species here and culture it, right? So I don't have to run through all of these regulations. I guess that's just main reasons. There may be other reasons that I'm not aware of, but that's just the overview of how I see why Pacific white shrimp and monodon is getting attention from researchers and commercial as well.
Thank you so much, ma'am, for your valuable insights. It was such
Thank
a
you.
pleasure to talk to you.
Thank you.
Anyone from the participant who want to ask a question? Okay. Alhamdulillah, with this enriching discussion, we come to the conclusion of today's session. On behalf of Tawakkal Group, I once again extend my heartfelt gratitude to Dr. Aya S. Hussain for sharing her insights and experience with us. Your journey and research are a source of inspiration for all of us in the aquaculture industry. I would also like to thank all the participants for joining us today. Your engagement, attention, and questions have made this session truly valuable. Let us remember that the future of aquaculture lies in the innovation, sustainability, and collaboration. By applying this knowledge gained here, we can make a real difference in our industry and communities. Thank you all for being part of this event. May Allah Almighty bless our efforts, guide us towards success, and bring barakah in our work. Until next time, stay safe, stay connected, and keep contributing to the advancement of aquaculture. Allah Hafiz.
Allah Hafiz. Thank you, everyone, again. Thank you for having me here today. I really appreciate it.
Thank you, ma'am. Thank you. Thank you so much.
Assalamu alaikum.
Wa alaikum salam.